Okay, so here's our last example of graphing a rational function. So let's look at this is actually example 8 out of the book. So it's f of x is equal to x squared plus 1 over x minus 2. The first thing we're always going to look for is vertical asymptotes. So we set the denominator equal to 0. So let's do that. I'm going to zoom in here a little bit so you can actually see it. So I'm going to have x minus 2 equals 0. So you know you're going to have a vertical asymptote at x equals 2. Let's go ahead and throw that on our graph real quick. I like to make my graph big, otherwise whenever I go to put it on there, I don't think it looks as nice. Now for this one, we only have one asymptote, which is fine. So we have our one vertical asymptote in the last video, one that we did, and I know you had a couple examples of PDF. But in the last video, we had a couple of them, so it's nice to see a variety is kind of what I'm trying to give you here. So with our one vertical asymptote, now we have to make the determination, do I have a horizontal or a slant asymptote? Yeah, we have a slant asymptote on this one. Tell me why. 1 degree bigger in the numerator. Good, so horizontal asymptotes are out, which also means this next section of does the function cross the horizontal asymptote is a moot point because I don't have a horizontal asymptote, so I'm not worried whether or not I can cross it. So let's go ahead and figure out our slant asymptote. Now when you do your synthetic division, remember you put a 2 on the outside because it's always opposite of what's down there. And then in the box I have a 1, 0, 1. So with our synthetic division, you drop that 1. 2 times 1 is 2. 2 times 2 is 4, which no one even really cares about that 4 because this 1 is my slope and this 2 is my y-intercept. So for my slant asymptote, we actually have y is equal to a 1x plus 2. So we're actually, which makes it slant because it's a slope and a y-intercept. So let's come back over here to our graph, pardon me, and go ahead and put that on the graph. So y is equal to a 1x plus 2 means you begin here at 2 at the y-intercept, and then I move up 1 over 1 to make another point. So it's literally graphing a line, and notice because it has a slope, this line is at a slant rather than horizontal or vertical. And you can put as many points in there as you desire. I always like to fill that bad boy up because that way I make sure I have a hard enough time following the dots, but the more dots I have, the easier it is to make my dashed line. Cool. So now I have one vertical, oopsie daisy, hit the wrong button, one vertical asymptote and one slant asymptote that we're looking at. Cool, let's throw some points on this bad boy and get this going. Nice, and it's nice whenever I have my slant asymptote, I don't even have to answer that next question. Does it cross the horizontal? Well, who cares? I don't even have one. So we go right to the problem and we find our y-intercept. So our y-intercept on this graph is going to be where I plug a 0 in for the x. So I'm going to scoot down here so we can actually have a little bit of workspace. I bet you we can get both of these on here. So if I want to plug in a 0 and then I'll get some number. So I have f of 0 is going to end up being 0 squared plus 1 over 0 minus 2. So f of 0 in this instance is a negative 1/2. My x-intercept, remember we're going to set the numerator equal to 0. So if I have some number and 0, when you set your function equal to 0, the denominator cancels out. So I really end up with an x squared plus 1 equals to 0. I'm going to go ahead and put in my x minus 2 just so that you can see when you multiply both sides by an x minus 2, I'm just left with the numerator. And then solve for x. So I'm going to subtract 1 from both sides. So that gives me x squared is equal to negative 1. Square root both sides. Anytime you physically make the square root symbol, what do you have to write? Plus or minus. Now what's the square root of negative 1? Ooh, look at this. Building on our previous information. You know I love that. It's I. Well, how in the world can I graph an imaginary number? That's right, ladies and gentlemen, you can't. So, if I cannot graph that I on there, what does that mean? No x-intercepts. Right on. So, if I don't have any x-intercepts, no problem. I still have this one y-intercept of 0, negative 1/2, so let's put that on the graph. So I'm at 0, and I'm going to go down to negative 1/2 and make my dot. And because I don't have any x-intercepts, I know my graph cannot go above the x-axis. And it is drawn toward my asymptotes, so my graph at this part is now drawn toward my asymptote and drawn toward my asymptote. I'm actually going to make that a thicker line so that you can tell the difference between my graph and the asymptotes. There it is. Look at that big thick guy. Okay, so let's zoom back out here a little bit and look at my graph. Our extra points come in handy when I'm trying to find gaps on both sides of the vertical asymptote. Now on this instance, I'm cool on this left side of my vertical asymptote because if I tried to make any vertical lines going down through here, I can't have anything on top because of my bottom. However, on this right side, I don't know. Am I going to have something down below or am I going to have something above? Let's see, shall we? So let's plug in a value and let's just make it easy. Why don't we go ahead and plug in 3 here? So I really just need 1 extra point on this graph. So let's come down here to our extra points. And now I'm going to go ahead and make a T-chart for my extra points. And I'm going to plug in a 3. So now I end up with f of 3 is ending up being 3 squared plus 1 over a 3 minus 2. So f of 3 in this instance is 10 over 1, which is just the same thing as 10. So now I have the point 310. Let's go ahead and graph that up here. So I'm going to make the point 310. I'm going to graph just a tad bit bigger so that we can see it a little bit better. And I'm going to go up here to 310 and make a dot. So this tells me that inside those two asymptotes is where my graph is going to be. So again, it is a smooth and continuous graph that I'm looking at. So there is my graph. Now, something I want to point out to you. Notice over here for my graph at the beginning, I could already look at this problem. Let me zoom in just a tad so you can actually see it. I could already look at this problem and tell you that it was going to be on the top for the second one because if the denominator is to an odd exponent, then I know my graph is going to go in opposite directions. If it is to an even exponent, my graph is going to go in the same direction. Exact same concept as with our polynomial functions. So if I end up with it being odd, then I know when I'm around my asymptotes, it's going to be odd. If this is an even, then around my asymptotes here, so whatever my asymptote is, it's going to go in the same direction. So whatever the first one is that you're looking at, you know the second one is going to do that. In this one instance, I know it was odd, so it's going to go odd around the asymptotes. That's just a little extra for you, just so that you can see that and go with it. Extra points are also an excellent way to do that. It just makes it nice to have extra tools in your bucket. Cool. Awesome. Enjoy graphing these, and don't forget on the last few problems you have to use this template in order to graph those on your paper, and you'll turn those in and get points for them. Good. Looking forward to talking about these in class with you.